Chapter 7, Human Population Change in the Environment. So throughout this chapter, we're going to talk about a variety of issues related to our population growth and how we impact the environment. Chapter starts out talking about India's population pressures, and then it covers various topics like population ecology, population patterns, demographics, and then some of the solutions, stabilizing world population, and how population and urbanization are related. India is the world's second most populous nation after China. Between China and India, those two countries account for about a third of the world's population. Both of those countries have been dealing with human population growth. For example, India has a government-sponsored family planning, economic development, and adult literacy programs that they use to try and address the population issues. As with anywhere else in the world where populations exceed the carrying capacity of the environment, there's going to be, the result of that is going to be environmental degradation. And of course then the problem becomes if we start negatively impacting the environment, which provides everything that we need for our survival, then that's going to impact our abilities to meet all of our needs. Another big challenge with countries like India is that in India's case, about 3/4 of the people live under the poverty level. For them, that means less than $2 a day. So again, like $100 a year, 76% of the people in India live on that very small amount of money. The graph does show that the average number of children born to Indian women has declined over time, and as a result of greater use of contraceptions. But as the book will cover later on, these again are very complex problems, and they're not only sort of biological problems, but social concerns are involved here, religious issues, and a variety of other things that are impacting us in trying to deal with the issues of human populations growing over time. So first, starting off talking about population ecology. First, what is a population? So population are groups of individuals of a particular species that are living in a given area. So we can see that we have a population of walruses on the image here. In any given ecosystem, there are going to be populations of different species of plants and animals. We as humans are a population, and again, we'd be regionally kind of grouped together. Population in certain cities, or a population of humans in a given country. And so whether we're studying plants or animals or humans, basically we're dealing with a branch of biology that studies individuals. So it's still population ecology. And population ecologists are concerned with how and why populations change over time. And we know that things we've already spoken a little bit about, things like competition affect populations, disease, predation. And so again, these are all factors that affect any population, whether it's humans or animals. Obviously, predation isn't an issue with humans, but disease, competition for resources, those kinds of things are again relevant no matter what type of population you're talking about. So we can put this into a mathematical equation that describes how populations change over time. And it's really fairly simple. Global growth rate is simply equated as the birth rate minus the death rate. So R being the rate of growth is defined by the birth rates and the death rates. So if birth rates are higher than death rates, populations increase. If death rates are higher than birth rates, populations will decrease. And again, that could be looked at a local level or a global level. So the local growth rate, though, is impacted by two other factors, and that would be immigration and emigration. So it's still defined as the birth rate minus the death rate, but then to that you add the number of immigrants, so individuals coming into a population, subtracted from the number of emigrants, people that are living a population. So for countries like the United States, birth rates and death rates are taken into account, but then we're also taking into account how many people are coming into the United States from a different country, and subtracting from that any individuals that are leaving the United States to move to a different country. But again, it's still, growth rate is still a function of birth rates and death rates, immigration and emigration. So again, the result of that is that if the number is positive, that means the populations are growing, and if the number is negative, that means the populations are declining. If the number is close to zero, that the birth and death rates are similar to each other, or the factors of immigration and emigration are similar, then you have what we would call a stable population. So again, an increasing population means basically a positive growth rate, decreasing means a negative growth rate, and a stable population, basically birth and deaths are equal to each other. This image on the page here shows an example of real population data, in this case for reindeer, going back to 1911, when originally 25 reindeer were introduced to the island. You can see the population steadily grew over time and hit a peak of about 2,000 individuals. But then what happened immediately after that? You see the population crashed, declined heavily, because at that point there were so many reindeer on that island that they destroyed their food, and especially then in the winter time when food was less available, they couldn't have enough food for all of them to survive. So basically that population crashed from having an insufficient food supply at the limiting time of the year. So this type of trend, having populations growing rapidly, but then at some point if they exceed the ability of their environment to supply food for them, they crash. And we see this time and time again with wild populations of animals. And so the concern then is that we as humans, as a human population on the earth, could go through this same pattern. In a minute we'll look at the human population growth, and just kind of keep this image in your mind as we look at the actual graph of the human population. So why did that reindeer population grow and grow and grow, only to basically exceed the number that the habitat could support? Well, I think we mentioned this a little bit earlier, that basically all living things have what's called a biotic potential, which is the maximum rate of increase given perfect conditions, you know, things like unlimited food or unlimited space. And basically this potential is affected by life history characteristics. So those might include the age when they're first able to reproduce. So animals or plants that can reproduce at younger ages typically might have a greater biotic potential. How long of the lifespan of the living thing it's able to reproduce. Most animals in nature, once they reach sexual maturity, typically are reproductively active throughout their lives. We as humans, for example, live long enough that, at least in females, there is a point at which females are no longer able to produce viable eggs. But in wild populations, generally they reproduce until they die of old age. And then how many reproductive periods there are. Again, humans on average could reproduce, make children every 9 months, because that's how long it takes for a child to develop. Mice are able to basically reach maturity in about 3 weeks, and they might have 6 or 8 reproductive events throughout the course of a year. So those kinds of animals have the greater ability to, again, reach their biotic potential. And then how many offspring are produced? Again, smaller animals like mice might have 6-8 babies each time they reproduce, whereas you look at something like an elephant. Typically, they'll have 1 calf every 18 months or 24 months, something like that. So in general, larger organisms, like I mentioned, elephants and whales, have a lower biotic potential than smaller organisms. So again, the main point of life on this planet is to reproduce. So all living things are going to try to reach their biotic potential. Again, the point being that if you put a lot of offspring out there, whether you're a plant or an animal, there's a good chance that some of them will survive till the next generation. So that's why on that reindeer graph on the previous page, we saw that population of reindeer was growing rapidly, even though it hit a point where the habitat could no longer support that many individuals. But populations are always trying to reach their biotic potential. So now we see the graph of an experimental group of bacteria. Basically, this type of experiment is done to show that populations can achieve their biotic potential, or what we also call exponential growth. And again, you see it starts off kind of slow over time, and because they're bacteria, we're talking hours, not weeks or years. And suddenly, when optimal conditions are available, populations are reproducing constantly, creating this J-shaped curve. Generally speaking, the larger the population gets, the faster it grows, because it has what we would call momentum. The more individuals there are reproducing, the greater number of offspring that can be produced. So again, this controlled experiment is a perfect example of an organism achieving its biotic potential over time, hitting the maximum reproductive rate. So, given that, why isn't the world overrun with things like bacteria or mice or flies, things that have a high reproductive potential, things that are trying to reach their biotic potential? Well, again, keep in mind we talked about the fact that biotic potential is based on an organism with unlimited food, unlimited space. And so we know there's really no such thing as completely unlimited resources. And so these factors that we term as being environmental resistance are factors that limit populations from growing exponentially forever. So again, they might grow exponentially for a while, but eventually there's going to be a shortage of food or water or shelter or some other resource. And then we also know that as a population grows, then the effects of competition are going to increase, because again, you've got more individuals competing for ever less resources. If you're a prey species, the more prey there is, the more likely a predator is going to be able to find you and eat you. And we also know that the higher density we find in a population, the more likely a disease can spread through that population. Just think about sitting in a class, for example. You're packed in a big lecture hall with 100 other people. Somebody in that room has a cold or the flu. It's much easier to pass it from person to person if you're all sitting close together. So eventually, as the environmental resistance factors kick in, a population's birth rate is going to decline. Again, less individuals are able to reproduce as effectively because there isn't enough resources for all of them. And then that results obviously in a greater death rate because of diseases and predation and that kind of stuff. So again, it's important to realize that all populations are trying to achieve their biotic potential, but all of the environmental factors are resisting that population from growing uncontrollably. third factor here that we have to consider is what's called carrying capacity, which is basically the largest population that a given habitat can support sustainably or over the long run. Keep in mind we're talking about being sustainable. We could put 100 head of cattle on an acre, but how long could they live there sustainably? A day, 2 days, a week? They couldn't stay there 365 days a year. There's just too many animals and not enough food for them. So the key to carrying capacity is what the environment can support sustainably, basically long-term, forever, however you want to think about it. The carrying capacity can and does change in response to environmental changes. If you have above average rainfall and you create more grass than a dry year, the carrying capacity of that environment could be higher one year and it could be lower another year, just simply dependent on the environment. When a population starts reaching carrying capacity, so this graph on the right shows a population of paramecium, a microscopic organism, that as time goes by and as the population grows, notice the population is growing quickly, and in theory then, from looking at the previous graphs, the population would keep growing and growing and it would shoot right past the carrying capacity, which is what happened to the reindeer population. It shot past the carrying capacity, so it basically crashed because it didn't have enough habitat. This experiment, though, shows what theoretically happens to a population. That as the population grows and as it gets closer and closer to the carrying capacity, what happens? Well, the growth rate starts slowing down and the population size actually levels off. So notice this is a S-shaped curve. And basically this experiment showed that even though there might be initial exponential growth, that in a simple, very controlled environment, the population of organisms are going to level off at a number that's just below the carrying capacity. So again, that number of organisms can be sustained if the number is not above the carrying capacity. But again, keep in mind this is a laboratory experiment, one species, a very controlled environment. So this is an example of what would happen to a population given time and, again, a very simple condition where it would tend to level off. But in, again, the real world, we're going to have situations like we saw with the reindeer. Populations are it's more about trying to reach your biotic potential. So the more realistically they shoot over their biotic potential, they shoot over the carrying capacity, they crash, they recover as the habitat recovers, and then they reach some sort of stable point in the future. So in the real world, populations rarely stabilize at the carrying capacity. They rise above it, they drop below it, they hover around carrying capacity, maybe a little above, a little below in a given year. And again, that's going to depend a lot on the habitat. So some populations that overshoot the carrying capacity do crash, and again, that's because basically they've exhausted their resources. Once that population crashes and falls below the carrying capacity, then we tend to start seeing the habitat recovering. As the habitat recovers, then the population of organisms starts rising again. And so again, it creates more of like a roller coaster look, up and down over the time as the environment changes over time. So now on to the human population. How does the human population growth compare to some of the examples we've just looked at? The realistic example of reindeer populations and the controlled lab experiment with the paramecium. Well, a little bit of quick history. Go back into the late 1700s, and Thomas Malthus wrote an essay on the principle of population. In a nutshell, he basically said that at some point in the future, the human population is going to exceed the carrying capacity, although he didn't use that term, but that at some point the human population is going to grow out of control, and then because of the effects of a large population on the planet, there's going to be death and famine resulting from that. So looking at this image, if we go to about his time period on this graph, you see the little mark on there that says Black Death. So that was the bubonic plague that killed a huge percentage of the population in Europe at the time. So the key things to look at here, for a long time, going about 8,000, well, from now, about 10,000 years ago, the population was relatively low. You see some little peaks and then some little declines, peak, decline, and then you see the big dip right at the Black Death. And then what happened right after that? Why did the massive growth start occurring right around the mid-1800s after the plague killed a lot of people? Well, it's going to be two factors. Either birth rates grew or death rates declined. Well, again, it's a little of both of that. Birth rates increased as we started developing better medicine, better treatment for problems and diseases, as we then started discovering vaccines that we could give our children so they didn't catch the diseases that were common prior to that. So that resulted in lower death rates. And largely that's the main reason why the human population has been growing exponentially since the mid-1800s. Better machinery to do work for us. Instead of having to walk behind a horse to plow our field, we came up with steam power and later internal combustion engines, tractors to disc large areas in less time. Better food production, better nutrition, better medicine, and a bunch of other factors all contributed to this exponential growth. So we'll get back to the future of the human population in a minute. So let's go back and kind of summarize some of the reasons why our death rate declined so dramatically. Again, greater food production because we had machines to do the work for us. Better and more accessible medical care because we were discovering microscopic things and we started learning more about medicine. A simple thing like just having a better water supply, improving our water quality, not having to depend on getting water out of the river anymore and having to drink it with whatever diseases might be in there. Simple water treatment dramatically increased our population growth rate because of it decreasing the death rate. And again, things like, indoor plumbing and sewer treatment facilities, improving the sanitation of the environment we lived in, which decreased our exposure to these environmental diseases that had previously been a large source of our death rate across the world. So, what about the future of the human population? It's continuing to increase right now. Math people would say it's increasing at an increasing rate right now. So again, we're looking at the human population trying to achieve its biotic potential. The rate of increase has declined a bit in the last few decades. We've only been increasing at a 1.2% rate worldwide, which is about half of what it was back in 1960. The average number of children born to each woman across the world is now about 2.5, whereas, again, not that long ago, it was much greater than that. There are a variety of projections on where the world's population is going to reach its high point. On the low end, it could only maybe grow another billion people from the 7 or so billion there are now. But on the high end, it could be 10 plus billion people, 3 or 4 more billion people that are on the planet now. And I've seen projections that are lower than that, and I've seen projections that are a lot higher than that. Again, the key is we really don't know. The one thing that we can do that no other animal on this planet can do as effectively is we can modify our own environment to be better for us. We, with our big brains and our opposable thumbs, made air conditioning so we could live comfortably in hot climates. We developed more efficient ways of heating homes to live in cold climates. So we have done a lot of things to our habitat that has raised the carrying capacity. If you think back to that graph a little bit ago that showed the human population, remember it was really stable for about 8,000 years. Why didn't it grow before the 1800s? Well, again, we talked about why, but the question is, that long straight green line really shows us what the carrying capacity of the Earth was prior to us developing all the great technology we did. So the only reason, one of the reasons our population has been able to grow as much as it has is because we keep artificially raising the carrying capacity of the Earth. So again, that's something we can do that other animals can't do. They can affect their habitat, but generally speaking, they can't improve their habitat to the degree that we can. So that's why there's such a variation between the estimated low and high population levels that we are predicting for the human population. So I kind of just alluded to what is the Earth's carrying capacity. Again, when we go back in time, before all the technology, the Earth's carrying capacity was much, much lower than the number of people that are on this planet now. Again, people estimate the Earth's carrying capacity to range from 4 billion to 16 billion. Again, why such a huge range? Well, again, there's so many factors. Among the ones listed here, the technological innovations is probably the biggest one. And maybe for the betterment of us, 100 years ago we couldn't have predicted a lot of the stuff that is common now. And so a lot of people are assuming or hoping that when we run up against other problems in the future, that we'll always be able to find some new technology to solve the problem. So how could we have a carrying capacity of 4 billion if our current population's at 7 billion now? And if the population's carrying capacity is 16 billion, does that mean the population's going to overshoot 16 billion like we saw with the reindeer population? And then what happens after that point? So what I'm trying to say is that although we as humans have a potential to greatly change our own carrying capacity, there's no reason to think that at some point our population won't be subject to the same laws of nature that reindeer population is subject to. If the carrying capacity is only 4 billion and we're at 7 billion now, are we due for a population crash in a year, in 10 years, in 100 years? Again, the challenge is we really don't know. And that's why we need to be thinking about this problem now before we get to a point where the population starts crashing and we can't do anything to deal with it. So certainly one of the many factors that have affected our population is the fact that we have continued to find better ways to produce ever more food for the number of people living on this planet. But you're going to hear this word a lot in this class, and that's thinking about it being a sustainable production of food. Again, optimistically, people suggest that decreasing the birth rate will stabilize the human population. Remember, it's really just birth rates and death rates if we're looking at the planet as a whole. So clearly we're not going to increase death rates to get the population to stabilize. We're going to have to find a way to decrease the birth rate. Now again, a lot of people do argue as well that it's not quite as simple as just decreasing birth rate. So along with that, you have others predicting that it's ultimately going to be the widespread destruction of the environment, which we do see already on this planet, that's ultimately going to be what causes the population to stabilize, but probably only after a large population crash. Again, we can look at so many examples where too many individuals, too large of a population in a given area, and again, I'm not specifically talking about humans, could be any living thing, puts stress on the environment when there are too many things for too little space, causing habitat damage, making the habitat less suitable for everything that lives there. Again, I would argue that of these two options, finding a way to decrease the birth rate or waiting for the environment to be destroyed to the point where there's a population crash, I would argue optimistically looking at affecting birth rate is probably the better of those two options. Now, the good news is that as populations in countries, as the countries develop, those populations tend to stabilize, and we'll talk a little later about the factors that affect that. The United States and other developed countries are already decreasing birth rates to the point where they're just growing at a very small rate. The bigger challenge, however, are the developing countries like India and China, where you've already got 2 billion plus people, and the birth rates are still relatively high. So those populations, as they continue to grow over time and still have less resources for those people, that's where some of the larger problems are going to be. But again, it's still not that simple, because even though there are fewer of us in the United States, 300 million or so, as we already talked about in Chapter 1, we're, as developed countries, we're about 1 out of every 5 people on the planet, but we're using 70 to 80% of the resources. So the developed countries are in many ways having a greater impact on the planet than the billions of people living in the less developed countries. But think about this: when those developing countries continue to progress and become industrialized and move through a demographic transition, first of all, how big are those populations going to be when they start stabilizing themselves? And then when they all use resources like we do, how much of a negative impact is that going to have on the planet? So again, I talked about the trend that, generally speaking, more highly developed countries, the more highly developed countries become, generally the countries have lower carrying capacities. But again, there are huge regional differences as indicated by this figure. So when we're talking about population ecology, demographics is actually the specific branch of sociology that deals with population statistics. And again, it's the same concept whether we're talking about humans or pine trees. So there are people specifically who study the demographics of populations, and in this case, specifically the demographics of human populations. So I've been talking about developed countries, developing countries. So what is that based on? Well, several factors play into defining what these countries are. The growth rate of the populations, how quickly or slowly the human populations are growing, the degree that these countries are industrialized, so the development of industries that make products for that country or to sell to contribute to that country's economy. And then this concept of prosperity, the gross national income in purchasing power parity is one of those factors that we look at to determine the relative prosperity of a country. When this number is divided by the actual number of people in a given country, It basically indicates the amount of goods and services that the average person of that country could buy in the U.S. So the average in the U.S. is about $45,640, and we're a developed country. If we look at the worldwide average, it's about a quarter of that value, a little less than a quarter of that value. So again, what does that number actually mean? Well, it's really more for comparison purposes, thinking of what a developed country is compared to a developing country. Developing countries are a fifth to a quarter of what the United States is with respect to the purchasing power. Another factor that we look at to distinguish developing and developed countries is the infant mortality rate. How many children under the age 1 there are per 1,000 births. In the U.S., the rate was 6.1. So about 6 out of every 1,000 children born in the U.S. die. Compare that to the worldwide average of 44. So again, a number that is substantially greater in those developing countries than in a developed nation like the U.S. Another factor, replacement level fertility, which is how many children a couple have to produce to replace themselves. So if you had 2 people making 2 babies, or just a hair more, so 2.1 would basically replace themselves. And if every 2 people made 2 babies, 2.1 babies, the population in theory would stay level, or basically growth rate would be 0. So the global fertility rate is 2.5, above the replacement level. It was actually as high as 6.1 in 1970. The total fertility rate in Brazil was 6.7, above the global rate, and today it's down to 1.9. So again, you can see examples in countries like Brazil where they have dramatically decreased their birth rates to a level where it's a more sustainable or stable number. Now, the other thing to keep in mind with this is a long time ago, if 2 people had 2 babies, they probably, the adults, probably would die, probably maybe before those 2 children had offspring of their own. Today, is that typical? What's the average lifespan of someone in a developed country? It's 76, 78, something like that. So how many generations of a family are likely to be alive at the same time? Could be several. So again, just having 2 children, and then those 2 children having 2 children each, and those children having 2 children each, and all of those generations being alive at the same time is going to basically result in still a growth rate increase in a population. So again, in general terms, highly developed countries have the lowest birth rates and the lowest infant mortality rates. The less developed countries have the shortest life expectancies, the highest birth rates, because they need a lot of children to help do the work that they need to do to feed the family. But they also have the highest infant mortality rate, which is another reason that they tend to have a lot of children, because you're never quite sure how many of them are going to survive. And then the moderately developed countries are somewhere in the middle. So let's look at what are the most crowded countries and the least crowded countries. Well, Table 7.1 has the top 10 most populous countries. And may not have thought about this, but the United States is the 3rd most populous country. But what's key here? It's also about how much land you have. So if you compare our density, how many people there are per square kilometer, we're among the lower end in this top 10. Only Brazil and Russia have lower densities than we do. Compare that to India, which is pretty high, but Bangladesh, they have the 8th largest population, but the highest density per square mile. So just, again, keep in mind that it's not strictly about how many of something there are. It's about how much space do they have, and of course, how much resources do they have. So again, China and India alone are over 2.5 billion people out of the roughly 7.45 billion people that live on this planet. And they're predicted to keep growing into the foreseeable future. Because again, large populations, even if their birth rate slows down, are still going to continue growing pretty rapidly for some period of time, even again when birth rates start to decline. So I mentioned the word demographic transition earlier. So basically there are stages that societies go through as they progress towards becoming industrialized. And we'll look at a graph in a minute. But basically, countries go from being pre-industrial to a transitional phase to then becoming industrialized to then reaching the final stage of being post-industrial. And again, we'll look at the graph here in the next slide or so. So this process is basically a transitional process where a country moves from very high birth rates and high death rates, again because of lack of clean water, lack of sanitation, lack of medical care, poor nutrition, to, as we move to stage 4, they have both low birth and death rates. So again, we look at a typical example here where we have the sort of orangish line that is the actual number of people, the population size, the blue line being the birth rate, and the black line being the death rate. So we go back in time on this whole planet, pre-industrial, where the high birth rates and death rates were happening because infant mortality rate was high, because people didn't live very long, but the population was low, and it was stable for a long period of time. And then, as it asks in the bullets above, where does the Industrial Revolution pop in here? Well, probably right at that point where the population starts growing rapidly. And again, why is that? Well, notice the birth rate doesn't really drop as the population size starts growing. But yet the population grows. Why? Because the death rate is starting to decline. So that transitional zone is where the birth rates are still relatively high, but the death rates start declining pretty rapidly because of basic betterment in health, nutrition, clean water, that kind of stuff. So the population's growing really rapidly during this transition phase. Again, because you still have a high birth rate, but now you have a low death rate. As you move into the industrial phase, notice the population is still growing in size, but what's starting to happen to the birth rate? It's starting to decline. But the population, again, still is growing. It's slowing down. It's not growing as rapidly because the birth rates are still higher than the death rate. And then what happens in developed countries that have reached that post-industrial phase is the birth rates and the death rates have equalized, and then eventually the birth rate actually starts going below the death rate. People are choosing to have fewer children. They have money. Both parents work. They may not have children at all. They may have children much later in life because both the man and the woman are educated and they seek careers. And what that results in then ultimately at the very end of this process is the actual population starts declining because the birth rate is starting to drop well below the death rate. So again, in these post-industrial societies, you actually start seeing a decline, not a crash, but a decline in the actual population. So the key thing is, worldwide, on average, where are we? We're still largely in that transitional phase. Some countries, like the United States, are somewhere in stage 4. Our population isn't declining yet. It's still growing, but it's growing at a very slow rate. There are some countries in the world where the population is declining. But remember, the two biggest countries, China and India, are still somewhere in that stage 2, where populations are still growing, and in some cases pretty rapidly. Again, we can look at a few examples here of countries comparing their total fertility rate from the 1960s to current times. And in all cases, the fertility rates have dropped. In countries like India and China, where I mentioned are the two biggest, rates have dropped dramatically in China, but not very much in countries like Nigeria. So even though, again, China and India are both showing lower total fertility rates from numbers around 6 per thousand to numbers maybe between 2.0 and 2.5, but those populations are still growing because, again, there are a lot of people, and if you have 3 billion people, even if they're only making 1.5 babies for every pair, that means the population is still going to continue growing, at least for a period of time. So along with actual population numbers, other factors like age structure plays a role in the demographics of a population. So basically we're looking at the number and proportion of people in each age category. And what this does is it allows us to make predictions about future population growth. The more young people there are in a population compared to older people, the more growth rate we're going to find in the future, because all those young people will reach reproductive age, they'll get married, they'll start having children. And we'll look at some age diagrams in just a minute. So the age diagrams not only show the categories of age classes, but also obviously the ratio of males to females, and they follow this pattern from basically birth to death. So the left side of the diagram we're going to look at represents males, the right side females. The bottom third of the diagrams represent people that are too young to reproduce, so children. The middle third represents the age range where humans are capable of reproducing. And then the top third are basically those people that are beyond reproductive years. So we got 3 examples here. An example in Ethiopia, where there is a very rapid population growth rate. And we can tell that by looking at this diagram because of how wide the base is. Again, we have pretty equal numbers of males and females, but if you look at the bottom third of the graph, there's a lot of people that are going to be coming into reproductive age. So as those people go into reproductive age, the bottom is going to keep getting wider and wider and wider because you have more and more and more people making babies. But also notice it has a very steep slope. And, you know, an average, I should say an oldest age category is getting into the 70s. Compare that to a population like the United States, where some of the oldest people are going to be up near 100. So again, it's how old those folks live. They don't live as long because of all the issues we've already talked about. They make a lot of children to help do the work, high mortality rate, but a very, very high birth rate. So the population is going to continue to grow. Again, you compare that to a country where the growth has slowed, hasn't stopped completely, but it's slowed. And you can notice kind of the bulge there that's highlighted as being the baby boom years. The people that were born from, say, the late 1930s, 40s through the 1950s and into the early 1960s, sort of the post-war baby boom. Now notice that part of the population actually is a bulge. the younger categories below that account for less people. So as the baby boomers kind of move up the graph there, then that bulge will eventually go away, and it'll actually start looking potentially more like a population that's in decline or no growth, like we see with Italy. So in the United States, we see a fairly stable base, pretty much straight up and down, whereas in the population diagram for Italy, the base is actually narrower than the middle of the graph. So again, there are fewer pre-reproductive people in the population than there are reproductive people in the population, meaning each of those people are having fewer and fewer children. So in the Ethiopia example, far more children than just the replacement rate of 2.1. In the United States, slow growth rate, a population level of just slightly above replacement rate, whereas Italy actually has a below replacement rate level of reproduction. And obviously, you could graph any country around the world, and there would probably be examples that are, somewhere between any of these three diagrams. But in general, be able to recognize by looking at the age structure diagram what a growing population looks like, what a slow growing population looks like, and what a declining population looks like. I've talked about momentum a lot. Again, the larger the population you have, the more momentum that population can build up. And so, current and future population growth rates are going to be hard to predict in some ways, because again, even if today China were to have a policy where every family could only make one child, and they've implemented something like that for parts of those kinds of countries, so you have two people making one baby, again, you're still going to have a population growing for quite some time, because people are living longer, more generations will be alive at the same time, and even 1 billion people only having one baby each is still going to be a great increase in population. So again, to affect the population, we can only affect the birth rate or the death rate. And since there's really no way to manage for having a higher death rate, intentionally anyway, basically our only impact can be on the birth rate. So whether it happens naturally or whether all countries start adopting some sort of programs to decrease birth rate, and if nothing happens, it'll probably decrease on its own eventually as we go through that demographic transition. But ultimately, stabilizing the world population is what we're trying to accomplish, however we're trying to accomplish that. Again, we're not talking about a herd of deer or a population of plants. We're talking about humans. So culture has a huge role in affecting population growth. The culture that a society has is based on the values and what the society considers the norms for that society, looking at what's right, what's wrong, what a person is expected to do or be, or how they're expected to act. And then you throw in all the differences in languages, beliefs, and spirituality, the role that different religions have with respect to things like birth control. All of those factors are huge. Again, society is driven by a lot of complex factors. And so it might be easy for the developed countries to tell the less developed countries to use birth control or just stop having babies, or tell them what they should do. But again, it's pretty arrogant of any country to think that they should or could be able to just tell other cultures how to act. We also have huge differences in the way we perceive gender, varying roles of men and women across the world. In some societies, men do certain types of jobs and women do other types of jobs. In certain societies, men are valued more than women. Male children are valued more than female children. So all of those cultural differences, again, play huge roles with respect to population growth in cultures. So it tends to be a function that women who don't follow any particular religion tend to have the lowest total fertility rates compared to women in countries who tend to follow that religion more closely. Again, examples within the Catholic religion where birth control isn't maybe looked at the same way as it might be with other religions or people who are not religious. So how does culture affect the total fertility rate? Again, there are traditions in all societies, and it is typical that a couple is expected to have the number of children that is normal for their society. I just remember growing up that a lot of my relatives who lived in the more rural part of Wisconsin where I grew up had a lot of children. I had a lot of cousins. In my family, it was just my sister and I, and we lived in a city, not a big city, I guess, but my dad moved to a city to work at an automobile manufacturing plant, and my uncle, one of my uncles did as well. They had 2 children. Compare that to my mom's and my dad's and my uncle's families. They all tended to have 4, 5, 6 children each. And again, up in that more rural part of the state, it was more traditional to have large families. Even today, I have cousins who still live in that part of the state who have 3, 4, 5 children, compared to relatives of mine that I'm thinking about that lived in other more urban city areas. So high fertility rates are traditional in some developing countries, partly because children are expected to work and contribute to their family's livelihood. If they live in or near cities, the children might be expected to work in factories. If they're in rural areas, they are expected to work on their family's farm to help grow and harvest the food. Worldwide, in 2008, 176 million children younger than 14 worked full-time, and many of them in hazardous jobs. So not only were they exposed to health hazards, but obviously if they're working full-time, they're not getting an education. And again, a big part of this is because these countries do not have the sort of welfare systems like we do in the developed countries. And so you're sort of creating your own social security by having a lot of children so that there are enough of them alive when you get too old to still work and support yourself. You have children that can continue to raise food and provide for you as you get too old to do those kinds of things. In many cases, children have less value as a source of labor in highly developed countries, so that frees them up to attend school. Now again, that wasn't always the case in the United States. Much earlier on, before we kind of moved into that later transitional phase, children in this country still worked. I think I already mentioned my grandpa on my mom's side was out working when he was just like 8 or 9. And basically that was what was expected of him by his parents, to help, contribute to the family by making money. They weren't farmers. They didn't live in a big city, but they weren't farmers, so he was expected to work. Highly developed countries, as they move through that demographic transition, and as they have more money, start being able to provide social services for people that are too old to work, or people that are unable to work for whatever reason. So again, a lot of this can be impacted or is impacted as you move through the demographic transition. Fertility rates drop by default as countries become more industrialized. a lot of gender inequality around the world as well. As I already mentioned, in many of the developing countries, women have far fewer rights than men do, which means they also have fewer opportunities for education, for example, and fewer privileges. That basically gives them a much lower political, social, and economic status. They're dependent on marrying someone who can provide for them, and in return they're expected to have children and run the household. So it's typical worldwide that more women than men tend to live in poverty because of all of these issues that, that again are typical of a lot of developing countries. So it's pretty typical in developing countries that there's a lot of gender discrimination. The percentage of women in developing countries tends to be higher than men. Again, the image shows that's pretty consistent across an example of some developing countries. 90 million girls worldwide aren't given the basic opportunity for an elementary school education. So if you're not getting an education, how are you ever going to make more money in the future? So low-paying jobs are typical. Unskilled jobs are typical for a lot of women in these types of countries. The women's age at marriage and their level of education directly affect total fertility rate. In developed countries like the United States, women get married older because a larger percentage of them get not only a high school education but a college education. Because they're educated, they seek career opportunities. And even when they get married, which again in countries like the US is more typical now, getting married into your 30s as opposed to the 18 years old right out of high school. They work longer, they decide they want to kind of get their career going before they choose to have children, or with both couples working, making good money, they just choose not to have children. So again, that's why the age at marriage and education affect total fertility rate. Where women get married earlier and they aren't given an opportunity for education, their social status and their economic future is dependent on marrying someone so that that person can provide for you. And then again, that means typically earlier marriage and more children. So as we already said, there's a correlation between higher education. The more education a woman has, the lower the total fertility rate. And again, we can see some examples of that illustrated on this graph. The average number of children born per woman. The brown bar is less than a primary education. The whatever color that is, gray bar, is a lower birth rate for women that have at least a primary education. And then notice the birth rate's even lower for women that have completed a secondary education. So primary would be the kind of, elementary school for us. Secondary would be at least kind of getting through high school. So even in these developing countries where women are given opportunities, you can see a dramatic decrease in the total fertility rate, leading to a more stable population ultimately for those countries. So in the United States, it's not untypical for women to give birth to her first child into her 30s or even into her 40s after establishing a career. So if you don't start a family until that much later in life, you're far more likely to have a much smaller family, or typically a one-child family. And again, we can see the average number of children born per woman being lower as the level of education increases in the United States, from a high of about 2.6 to just say about 1.3 for women that have a graduate or professional degree. just the access to family planning is a huge factor in lowering total fertility rates, increasing the availability of prenatal care, being able to take care of babies, give them the immunizations, and teach the parents how to take care of their children, lowers total fertility rate, providing information on the use of contraceptives lowers the total fertility rate. But again, it may be possible to expose women to these things, but it still may not work or may not be effective because of the differing cultures and religions that are in play out there. Again, some examples of showing decreases in total fertility rates where contraceptives were simply made available. In highly developed countries, 72% of married women that are of reproductive age use contraceptives. The number for some of the developing countries, like we see on this graph, are in the teens to maybe 20s, as opposed to, again, 3/4 of women in developed countries. And again, it seems like pretty straightforward. If you use contraception, you're far less likely to have children. But again, it's not that easy when you're dealing with cultures and societies that have different perspectives on these things than the developed countries do. So another What a Scientist Sees for you to read. One of the ways that some of these developing countries are trying to encourage women to not necessarily get an education, but to establish a business so that they can, provide for themselves or contribute more to the family, which would result then in lowering the birth rate. Programs that extend small loans to women to establish businesses, and it targets women as 70% of the world's poorest people are women, as we've already talked about. So basically providing mothers with a way of employing themselves is believed to really help curb the effects of poverty and hunger on children. It may or may not have an impact on lowering the birth rate, but at least it provides more income for those families to be able to provide better nutrition and care for their children. Urbanization is basically the movement of people from rural areas to cities. And around the world, this trend has been occurring. This is one of those steps of getting to that later stage of the demographic transition. As a whole, we have moved from being farmers and building our own homes and growing or hunting our own food, to moving to cities for better paying jobs, higher standard of living. About 79% of people in the United States live in cities. So even in developed countries, that number is really high, maybe even more than what you might think. There are still lots of rural occupations, people that fish and farm and log for a living, still very important. Farmers, providing food to all the other people that don't grow their own food anymore, which is most of us. Or we might grow a garden, but we can't provide everything we need. So the farming, ranching, logging, providing raw materials, all those other occupations are still obviously very important. And what's a challenge, probably more than anything else, is because of this move towards cities and more of us living in urban environments, we've really lost our connection with our environment. It's that old thing that you've probably heard, you ask a kid from Los Angeles where milk comes from, and they say the grocery store. Where does that wood come from for our wooden deck? Well, it comes from the store. That kids have, because they don't live in these areas anymore, and they don't live on a farm, and they don't have to take care of the animals every day. They really don't connect food or products with our natural environment. And so every day that passes and every day that more people live in cities, we have a greater challenge ahead of us to try and keep those people educated about our environment, on using our natural resources, where these products come from. Cities are really ecosystems, not natural ecosystems, but urban ecosystems. They're their own little self-contained thing. Fuel comes in, our natural capital, again, stuff that comes from the environment, but it comes into the city, and then, again, people lose track of where that stuff comes from, and then they produce waste products that leave the city. So we, again, have resources flowing in and out of cities, but people don't know where the resources are coming from, and they don't know where the waste products are going. So it's easy to develop that attitude of, as long as I don't see it, then it can't be a problem. If it goes away from me as air pollution or waste or whatever, as long as I don't see it, it's probably okay. And that's exactly the problem that we have. If all of us don't worry about where things come from to notice if there's a problem, and we don't care where things go to recognize if there's a problem damaging the environment, then we're going to continue to be in a greater negative, bad situation than we are now. There are specific environmental problems related to urban areas, things like brownfields, areas where basically old factories have been abandoned, or suburb areas, residential areas that have been abandoned, or past factories, past chemical plants, where basically they've contaminated the area from whatever they used to make in the past, and basically they sit vacant now because they would have to be cleaned up before they can redevelop those areas. So, because that's expensive, they just sort of abandon those areas and move a little farther away and then start developing something in a suburb that keeps expanding the city, creating urban sprawl, which continues to then encroach, the city continues to encroach more and more into those areas that were once natural, or those areas that used to be farmland, or those areas that used to be a forest. So lots of urban sprawl is occurring around the world. There's an emphasis to try and do a better job of planning cities to grow up, not out, so that they don't have a bigger footprint than they do right now. And there's certainly laws and regulations that deal with brownfields, but again, there are still so many of these problems out there that it's going to be a long time before we probably have really addressed these issues. So because these developments keep spreading out, it becomes more and more important to have an automobile so that you can get to work, so that you can get to where you buy your food, your groceries, those kinds of things. Again, we've already talked about how cars are responsible for, among all the other things we use, among the most pollution to the environment. It's especially bad in and around cities because that's where the bulk of the people live. So the higher density you have in urban areas, the greater amount of pollutants you create, not only from cars, but from the industry that develops in those cities. Then you add to that the fact that cities by nature are created by a lot of hardscape. Parking lots that are paved, streets that are paved, hardscaped buildings. So the water that actually lands on the cities doesn't even get into the groundwater, which would then be available for us to use. It gets funneled into a gutter system and then gets directed out to the nearby rivers, lakes, and oceans. So we're losing a huge ability of the environment to recharge itself, to keep that water cycle functioning like it should. And then, of course, a lot of times that runoff doesn't get treated. And that runoff carries with it all of the pollutants that basically were on the ground. And so you're contributing to the air pollution, the water pollution, all the other environmental and health hazard issues. And because of that, urban areas in the developed countries are bad enough, but urban areas in developing nations have the worst air pollution in the world. You've probably have seen on TV images of people walking through cities like Mexico City or Shanghai or some of the world's very large cities. And they basically can only do that wearing face covering, little air, I can't think what the blasted things are called, but those little white masks that you wear over your face to hopefully filter a little bit of the pollutants out so you're not breathing them in. Again, that's a huge problem that's not going to go away anytime soon. It's only probably going to get worse as these countries continue to go through the developing stages, to move through that demographic transition. There are benefits, though. It's not all bad of urbanization. Well-planned cities, which we are seeing more of in developed countries, have programs of planting trees. Laws that require new building or new construction incorporate trees, which help, capture air pollutants, help clean the air, help shade the ground, which means obviously then you're also going to have bare dirt where those trees are to help absorb some of that rainwater. And again, as we continue into the future, there's going to be more and more development where the cities grow up rather than spreading out. Places like Portland, Oregon have built up, developed multi-unit residential buildings that are close to shopping centers, jobs, transportation, kind of like a bunch of little cities within a big city, so that you're not needing to drive all over the place to meet all your requirements for the products you have to buy. They're all available within sort of a neighborhood. And because there's public transportation, or because it's close enough that people walk or cycle to work or to school or to the grocery store, it becomes much more efficient and therefore generates less pollution. Again, that's the ideal situation, and there are more and more cities that are very seriously looking at this concept of compact development. But the biggest problems in the biggest cities in the world, and especially in the developing countries, they can't just jump from where they are now to this ideal, compact development. It's going to take a while, like it took us. So unfortunately, there's probably going to be a lot more pollution occurring until these kinds of problems are able to be addressed. So worldwide, a little over half of the population live in urban areas compared to the developed areas where it's much higher, as we saw. 400 cities in the world have more than 1 million people. 46% of the population in developing countries are urban. So again, on average, about half of the people in the world live in urban areas and about half live in rural areas. Megacities are becoming a little more common, just because as our population keeps growing, you're going to have more and more people moving to cities to try and better their quality of life. So megacities are defined as cities that have more than 10 million people. So we've got places like Los Angeles, Mexico City, those kinds of places that are considered megacities. Again, just a graph kind of showing the trend going back to 1950 as we've changed from higher urban populations and lower rural populations. You see that in worldwide, we hit the sort of 50% ratio in 2008, and by 2030, it's predicted, as you can see, how much more people will be living in urban populations, again, worldwide, than will be living in rural areas. So obviously a big part of a demographer is to predict the future. And so if we project the world's 10 largest cities out to 2025, 8 of those 10 largest cities are still going to be in developing countries. Again, New York predicted to hit about 20 million, Mexico City 21 million, Tokyo, Japan is the other developed country, which is predicted to be at over 36 million. But again, what's the real problem here? If these megacities, if 8 of the 10 largest cities in the world are in the developing countries, the ones that can least provide the resources that those people need, this is where we have to start really worrying about that population chart. You know, how close are we going to get to a major population crash? It may not be worldwide. It may be locally first, which is, we've kind of already had population crashes locally. But when we start having cities that have 20, 30, or more million people in them, it's going to be very important for those cities to provide for those people. And if they can't, crime rate starts increasing, people won't have basic health care, there will be higher mortality rates, all sorts of potential problems because of these cities being in those developing countries. So again, it's not really a simple solution to a complex problem, but how do we meet the challenges of these fast-growing cities? Again, it's pretty simple, not simple to apply, but it's simple to understand that you need clean water, you need sewage treatment, you need to provide your people with education so they can be a part of the solution to the future. If they're not educated, they're just going to be a drain on society, whereas if they're educated, they're going to be able to help create solutions to the future problems. You got to have adequate housing to deal with all the people that are coming in from the rural areas. Although cities do offer more job opportunities, that sort of urban growth in developing nations can easily outpace the economic growth. So again, that's a huge concern, growing and developing sustainably. And of course, issues like poverty, unemployment, violence, the degradation of the environment, waste disposal issues are still not only impacting fast-growing developing cities, but these are all still huge concerns for developed countries as well. So again, it's going to be a bigger challenge in the developing countries, but it's still a challenge in many of the developed countries. So this chapter ends talking about a case study related to urban planning in a city in Brazil. So this is another one of those examples of compact development like we saw with Portland, Oregon. 3.1 million people that live there. The development of efficient mass transit and traffic management that allows about 2 million people, so 2 out of 3 million people using the mass transportation system every day to get to work, to get to shopping, those kinds of things. This is probably our biggest challenge. How many of us are willing to give up our cars for the sake of the greater good? Now again, not every area in California has mass transit that can get you anywhere you need to go. But again, our culture in the developed world is very heavily on our automobiles, the independence that we get from them. But again, where that hasn't been something that became part of our culture, like it hasn't in Brazil, they're able to utilize these systems much more efficiently. It's also the first city to use low-polluting fuel that burns cleanly, biofuels. There's a whole another challenge with those that we'll talk about later. And also labor-intensive garbage purchasing program, basically where poor people are able to exchange their garbage for bus tokens, food, notebooks for their kids to go to school. Again, rather than just dumping it somewhere in the environment. The government is incentivizing the population to not pollute the environment by, again, providing them with something that is of economic value to them. And so again, just some images of how the bus network is arranged, and some examples of the downtown area, how it looks. So again, of all the chapters in the book, I've talked about how humans are responsible for all the problems on this planet, so we have to be the solution. A lot of people, again, want to say that it's as simple as decreasing the birth rate. And yes, although that would start to improve some of the challenges we have, there are too many culture and social and economic issues for any one country just to tell another country to quit having babies. It's not that simple. And again, it's not always simply about the number of people. It's about the availability of resources and the type of resources that are used. Using resources that are damaging to the environment could be bad if there were only 1 billion people on the planet. But we could have 10 billion people on the planet, and if we were all using green resources, if we were all using solar or wind, or we were all growing a portion of our own food in our yards, those kinds of things could raise the carrying capacity of this planet to a level that could be sustainable even with 10 billion people. But then other people will also argue, is it about the quality or the quantity? We could support 12 billion people on this planet, but how is the quality of life going to be? Because how much are we going to have to damage the planet to be able to support that many people if we don't quickly go to more green type of resources? So we'll save a lot of those topics for the coming up chapters.